Hello everyone. In this video, we learn how to use Arduino Uno board. We'll try to connect the Arduino Uno to our computer, and we also try to write our first code and flash it onto our Arduino board. So let's get started. Before getting started, we'll see some of the materials required to start your journey with your Arduino Uno board. And also, we'll try to learn some of the features of this board. Let's see the materials required. First of all, you need an Arduino Uno board, and you need a USB type B cable and a computer. We'll see some of the common connectors which are available in the market to connect your microcontroller boards onto your computer. So for this particular video, for this Arduino Uno, we'll use something called USB type B. So this is how a USB type B looks like. So this is USB type B, and then we have a mini version of USB type B which is called USB type B mini. So this is a USB type B mini. So boards like Arduino Nano uses this type of connector. So and then we have most recent version, this is USB type C. And then lastly we have my USB micro USB. So this is how micro USB looks like. So you may find it in the phone charger pins. So it is almost phased out now. So it was popular in the last decade. And then the other end of all these USBs, we find USB type A. So this is USB type A. So we'll see the basic structure of Arduino Uno. So firstly we have a USB type B port which is used to connect Arduino Uno to the laptop or a computer. So then we have a power jack. If you want to connect your Arduino Uno to external power supply, you can power with this. Then we have input output ports. So this is mainly digital ports, and we have analog ports here. Then we have power ports, and then we have the microcontroller itself. So Atmega 328P is used as a microcontroller in this Arduino Uno board. And we also have a reset pin available here, the reset button, sorry. And then we have a 16 megahertz crystal. So this is a basic structure of Arduino Uno, and then we also have several LEDs present on board. We'll see how to connect Arduino Uno to the computer. Firstly, take USB type B end of the USB cable and connect to the USB type B port present on Arduino Uno. Then take the other end of the wire, the USB type A, and connect to the laptop port. As soon as you connect, you will see a green LED glowing on the Arduino Uno. That means it is powered up. Before we program our Arduino Uno, it is important to learn something more about Arduino board. So for that you can visit the documentation tab in Arduino homepage and navigate to hardware, and then select our board, which is inside the classic, and Arduino Uno R3. So you can find more information on Arduino Uno here. So let's go to datasheet, and this is Arduino Uno R3 itself, and then we have some of the features of Arduino Uno. You can see there are two important features that we can see. One is it has an Atmega 328P processor, and it also has an Atmega 16U processor on the Arduino Uno. So comment down below why two processors are used inside the single Arduino Uno development board. So maybe you can take a hint when you come to the board itself. You can see where this is placed, Atmega 16U. So this is placed near to the USB type B connector. So comment down below why two processors are used. So we all know that our main processor is Atmega 328P. So when we are having our main processor, why there is a use of Atmega 16U processor. Okay, so then we have okay, then we'll see what is this Atmega 328P. So 32 means 32 KB flash, 8 means it's an 8-bit processor, and then P means it's pico power. So Atmega, there is two versions, Atmega 328 and then Atmega 328P. So P simply means that it's pico power, and then it uses less power compared to Atmega 328. Okay, so this is some of the features of our development board, and then we have the board topology, and then some power tree diagram. So you can see the two processor, one is Atmega 16U and then Atmega 328P, which is our main processor. So this draws 261 milliamps of current, and this one 410 milliamps. And then we have an onboard green LED which uses 5.6 milliamps, and then we have 4 yellow LEDs present on the board. So comment down below if you can see 4 LEDs, you can spot all the 4 LEDs and where it's present on the board. Then we have a 3.3 volt output pin from Arduino Uno. So LD0 is I think low dropout conversion type, and then op amp is another conversion type used for the power conversion. Then we have the pin configuration and the mechanical properties and features and some certification. Yep, so that's it. You can visit the Arduino website to see more about the Arduino Uno. So let's get started to program our first code and then download it onto our Arduino Uno. Okay, now we'll try to program our Arduino. So once you connect your Arduino to your computer, you can see a green LED which lights up. So next we'll see how to program this Arduino. So as I explained in the last video, we have two sections. The first section is called void setup and the second section is called void loop. So inside void setup we need to write the program or the setup code which we need in our project. So now we'll try to blink the onboard LED which is present on the Arduino Uno. So we know that the LED, the onboard LED is connected to pin number 13. So let's go ahead and make that pin number 13 as an output pin. So to do that we need one function called pin mode. So notice that P is in small letter and M is capital. Pin mode 13 comma output. So this is the syntax. Okay, so now the setup is complete. So what this actually does is it will set the pin number 13 as an output pin. So next step is the void loop. So inside void loop we are making the LED glow for 1 second and then it should be off for another 1 second. So to do that we need to use a function called digital write. So we can notice that D is in small letter and W is in capital. Digital write the same pin number 13 comma high. So what this line of code basically does is it will give a 5 volt to the pin number 13 so that when you connect any peripherals like LED to that, so it will get 5 volts. So that's the meaning of 13 comma high. And then we need to delay it. So for that we have an inbuilt function called delay. and we give 1000. So whatever we write inside delay is in milliseconds. So this basically delays the program by 1 second. Then we need to write digital write 13 comma low. So what this basically does is it will make the pin number 13 as low. That means it will cut off the 5 volt which is supplied. So basically the LED goes off. Then we need to make it off for another 1 second. So 1000 milliseconds. So that's it for the program. So it will make high for 1 second and then off for 1 more second, and then this loop continues. So let's go ahead and dump it onto the Arduino Uno. For that you select your Arduino Uno board from the board manager, Arduino Uno, and then select the correct serial port. If the serial port is not displayed, you can go to the device manager. So inside device manager, inside the ports, you can see Arduino Uno, or you can see one of the COM port has missing drivers, so you can go ahead and update the driver if the COM port is not selected automatically. So in most of the cases, once you connect your board, it should automatically detect that, and then it will show the COM port here. Alright, so let's upload this. So first click on compile. So let the program compile. As you can see, we have no error, and then click on the upload button. So once you click on upload, you can see the RxDX LED is blinking, and then you can see the LED, onboard LED, which is blinking. Yes. Okay, so this is it for the program, and we successfully uploaded the code onto the Uno board, and then we were successfully able to blink the onboard LED just present on Arduino Uno. Okay, so in the later videos we'll see how to write the programs effectively and with less complications. Alright, so that's it for this video. Hope you understood how to write your first program and upload it onto the Arduino. So in the future videos we'll do more such projects, and we'll try to learn more about the microcontroller and the projects. Thank you.